Hello. Today we are going to look at finding the coefficients of functions. And we're going to start off by reminding ourselves of what coefficients are. So if I have a function or an equation here with 2x minus 5y minus 4 is equal to 0, my coefficient is the number in front of the letters. So 2 is the coefficient of x. It's the number in front of x. Minus 5, and the sign is important. So here we had a plus 2, here we have a minus 5 is the coefficient of y. And we would say that minus 4 is the constant. So a number that doesn't have a letter multiplied by it or connected to it is going to be a constant. It won't change over time. This term will remain the same regardless of what x and y do. Whereas here we have a coefficient to a variable. So this term here, this minus 5 times y, is going to change as y changes because y is a variable. So that is our initial piece. We have our function, which is a relationship between our x's and our y's, our inputs and our outputs, and we have the coefficients, are the numbers that are multiplied by our variables, by our letters. A connected point to that is going to be how we figure out if a point, an x and y coordinate, are on a line. And this will be important for solving our problems. So if we have a function like y is equal to 2x minus 1, we would say that this is a description of a relationship between x's and y's, between inputs and outputs. So if a point is on this line, and this is the equation of a straight line, then when we sub in a value for x and y, it's going to make the equation work out. It's going to make the function get solved. So let's take an example. I'm saying that the point 0, minus 1 is a point on this line. What does that look like in terms of the maths? Well, I have y is equal to 2x minus 1. So this is my x and this is my y. So I have y is minus 1. I sub in brackets. 2 on 0 for my x minus 1. 2 by 0 is 0. So I'm just left with minus 1 is equal to minus 1. Now that is true. Minus 1 is equal to minus 1. So that point must be on this line. Or to put it in more formal language, that point, that coordinate, must be an element of the set of that function. So remember that functions can be thought of in terms of sets. So this coordinate here, this ordered pair, this couple, is an element of the set of points that are on this function. So let's have a look at this in graphical form. So we have our function here, y is equal to 2x minus 1, graphed, that's our light blue line. And we have the point that we just looked at, 0 minus 1, we can see visually is on that line. And another point that's on the line is 2, 3. X is 2, y is 3, so in the door 2, up the stairs 3. But if we look at the point 2, 1, in the door 2, up the stairs 1, that point is not on the line. What does that look like if we sub into it? So we have our function y is equal to 2x minus 1, and we're interested in the point 2, 1. So that's our x and our y. We know when we sub in a point that's on the line, we get the equation working out. It solves the equation. But what happens when we sub in something that isn't on the line? Well, we have 1 for our y is equal to 2 on 2 minus 1. So we have 1 is equal to 4 minus 1. 1 is equal to 3. Well, that's not true. 1 is not the same thing as 3. So this is how we can see that a point is not on a line. This is not an element of the set of this function. So if we have a point that's on the line, I'm going to do one more. I'm going to take that point 2, 3. We can see visually it should be on the line. And when we sub in that value for x and that value for y, does it solve the equation? We have 3 is equal to 2 on 2 minus 1. 3 is equal to 4 minus 1. 3 is equal to 3. That's true. 3 is equal to 3. So we can see that when we sub in points that are on our line, that are elements of this blue set of a function, then we get an equality that is true. We get -1 is equal to -1, or 3 is equal to 3, or 0 is equal to 0, whatever. We get something that is true. We get a true equality. When we sub in something that is not on the line, when we sub in a point that is not on the line, we get stuff that isn't true, like 1 is equal to 3, which is nonsense. This can be used to help us find coefficients, and that's why we're talking about it now. Because if we have a function like y is equal to ax minus 3, a being the coefficient of the x term, and we know that 2 minus 5 is a point on the line, we are able to use that to find a, because we know if we sub in x is 2 and y is minus 5, this equation must work out. We must get 3 equals 3 or -1 equals -1. We must get an equation that's true. So that means we can sub in x is 2 and y is minus 5, and this equality must work out. So -5 for our y is equal to a times 2 minus 3. So I have -5 is equal to 2 times a minus 3. I've done my multiply. Now I need to rearrange. So I need to add 3 to both sides to get rid of my -3 here. So I have -2 is equal to 2a. Divide both sides by the coefficient of the a. And therefore I get that -2 divided by 2 is going to leave me with -1. So a must be -1. So this is how I can use the fact that a point on the line solves the equation to find my missing letters. So can I do this here? I'm going to break up my line a little bit so I have more space. F of x is equal to bx plus k. So I have lots of letters going on this time, but they've given me 2 points. So if 0, -2, and 1, 2 are elements of f of x, that means these points are elements of the set f of x, so they're on the line. Find the values of b and k. If I ever get something that has a 0 in it, I'm going to try and use it first, because 0 is going to tend to get rid of stuff for me, particularly a 0x. Here is going to leave me with an equation that only involves k. So I'm going to start off with 0 minus 2 with my x and y. And I know that f of x is the same thing as y. It's another way of writing the same thing. So I have -2 is equal to b on 0 plus k. So k just ends up being equal to -2. That was fairly straightforward. And I know that at 1, 2 is also on the line, so I could take the x and the y for that. And I sub that in, and I have y is 2 is equal to b on 1. But now I also know that k is -2. So I can sub in my -2. So I end up with 2 is equal to b minus 2. I have to add 2 to both sides to get rid of the -2 next to the b. And I find that b must be equal to 4. So now I found my values for b and k. So always try and use, if you're given something that has an x is equal to 0, that is going to give you where we cross the y-axis. It's called the y-intercept. Because x is always going to be 0 on the y-axis. And that's going to give you our crossing for our y-axis. And it tends to be an easy one to find. So we should always try and do, where x is given to us as 0, we should always try and sub in that point first. So finally, let's go through this example here. We have another way of writing a function. F colon x goes to this. A function involving x will send x to this. But I know that that's just a funny way of writing y. So now I have my 2 points and I want to find b and c. So I sub in x and I sub in y. Again, I'm going to break up my page. So I have y is -3. Brackets, always sub in brackets, is equal to, so that arrow there I can just write as equals, it won't make any difference, 0 squared plus b on 0 plus c. So they're just 0, so I end up with c is equal to minus 3. This is where this quadratic, where this squared function would end up crossing the y-axis. So I know the point 0, minus 3 is on my line. And that gives me my y-intercept automatically. So now I'm going to take my other point, and I now know that c is minus 1. So I have x is minus 1 and y is minus 4. So I have minus 4 is equal to x squared, so minus 1 squared plus b on minus 1. And I now know that c is minus 3. So I have minus 4 is equal to minus 1 squared. Minus 1 by minus 1 is going to give me plus 1. Minus 1 by b is going to give me minus b and minus 3. And then I rearrange my equation. I have like terms here. So I can have minus 4 is equal to minus b minus 2. And I add 2 to get b by itself. So I have minus b is equal to minus 2. And I want to know what b is equal to, so I have to divide both sides by minus 1. So therefore b is equal to plus 2. Minus divided by minus is plus. So that is how I can use the fact that I know a point on the line solves the equation to find missing coefficients in simple functions. And that's what we need for right now.